video is just going to kind of talk through a little bit of the overall view of the chi-square test of independence process. I'll let you know what I want you to write down. It's not a whole lot. Okay, so remember this example we've already talked about where we have the driver's test people and we had 60 people. We went out and surveyed them and we got our observed values in this box. And then we went out and calculated our expected values. And then we calculated using our chi-squared formula to get the chi-squared value of 7.5. So we've done all that already. We want to find out, what does this mean? And that's leading us to this next slide. What are we going to do with this chi-squared value? We're going to do some hypothesis testing. We want to prove that there's a connection that exists between the two variables. Start by supposing there's no connection, called the null hypothesis. Find the probability that the connection will occur. Is there a chance less than 5%? Remember we talked about that 5%? This is called a significance level, that we reject the null hypothesis, hence a connection between the variables exists. All right, so far you haven't had to write any of this stuff down. All right, what we're going to talk about next is called the degrees of freedom. Go ahead, you don't need to write any of this down either. The distribution of chi-square statistics may be specified given the preceding experiment were conducted an infinite number of times and the effects were not real. The resulting distribution is called the chi-square distribution. So there's this little curve here. And the chi-square distribution is characterized by a parameter called the degrees of freedom. So if you remember your graphing calculator lesson, we calculate that degree of freedom with our calculator. And it determines the shape of the distribution depending on how many pieces of information we have in there. Is it 5 rows by 3 columns, etc.? That makes a difference. So here's just a couple examples of a degree of freedom of 2. So not as much data going on. If we have degree of freedom of 10, we have more data, more things going on in there. And then here is just another picture, degree of freedom of 1, of 4, of 20. Okay, that's going to help us later on. And how we calculate. This is what I do want you to write down, is this piece right here. The degrees of freedom can be found by taking this equation right here. The number of rows minus 1 times the number of columns minus 1. And then we're going to use a table. We'll be more familiar with this table later on. There's a significance level, which we want to focus on in our class 5%. And then a degree of freedom column. So let's say we have a degree of freedom of 5. Then we have 5% area underneath the table, so we have a value of 11.07. Here's what this says. From the chart, you can see that there's a chi-squared value of 0.05 can be 11.07 for 5 degrees of freedom and a significance level of 5%. You're probably like, holy cow. If the x value is less than, then the null hypothesis would be rejected and a connection between the two variables exists. There is some kind of, they're dependent on each other. If the opposite, the chi-squared values are greater than 11.07, it would be too great between the differences of the expected and observed and the null hypothesis true. There would be no connection. They are considered independent of each other. All right, last thing. I do want you to write down this picture right here. We're going to refer to it later. The area of rejection. So remember this degree of freedom curve that we've talked about? So this would be our curve, depending on what the degree of freedom is. And then we have this area in blue under the curve. There's a number of a chi-squared, critical, you can either go to the right or to the left. And the area of rejection is to the right. And here's what it says again for us. And this is what I do want you to write down too. If it's greater than, if your chi-squared value, which we did on the formula, is greater than the critical value, which you're going to get from your chart, then we reject the null hypothesis and accept the alternative. And then again, the opposite, if your chi-squared value is less than the critical value, then we accept the null hypothesis and reject the alternative, that they're independent of each other. So this would be considered independent. These would be dependent. So if you think about greater than, so that would be falling in this blue region, it's greater, they're dependent on each other. If it's less than, it's in this area here, then we accept the null hypothesis that they are independent. Yes, this is overwhelming. I'm sorry. We're going to spend 3 days on this, and it's going to take some time.